Right, so we are looking at differential equation. We said a differential equation is an equation which contains variables and their derivatives. For example, let me try to write here. Let me select the ink. Right. So for example, let's say we have y. With y is equal to 2x plus 4 dy dx plus 4 dy dx. So this one is it's an example of a differential equation. Why? Because we are saying we've got variables. Which are the variables?
X and y.
X and y, right? And its derivative. So this one it's a differential equation, and the derivative is the first derivative, right?
Yes.
It's only the first derivative. So we refer this differential equation as the first order. We refer this one as the first order. The first order differential equation. It's of the first order. Why? Because we have got the first derivative. So this one is the first order differential equation. And suppose maybe you are given maybe 2xy, maybe you are given 2xy minus d squared y over dx squared is equals to 7. Right, this one we now have the second derivative, right?
Yes.
So this one we refer this one as to the second order differential equation. But under your syllabus you don't do this second order differential equation. You only do first order differential equation. You only do first order differential equation, because as you can see here, yes, you only do first order differential equation like this one, first order differential equation, right?
Yes.
Right, so can you write the next point? There are two types of solutions. There are two types of solutions to the differential equation. There are two types of solutions to the differential equation. There are two types of solutions to the differential equations. Number one, we have what we call the general solution. Can you write the general solution? Then under that, just say it is a solution which contains a constant of integration. Under that, say it is a solution that contains the constant of integration. It is a solution that contains a constant of integration, right?
Yes.
Then solution number two is what we call a particular solution. It's what we call a particular solution. So under this, say it's a solution that does not contain a constant of integration. It is a solution that doesn't contain the constant of integration. Right, are you done?
Yes.
Okay. So can you write stages or a procedure for finding the solution of a differential equation? Procedure for finding the solution of integration. Number one, you say separate variables. Separate variables. Step number one, separate the variables. When we are saying separate variables, we are saying the x terms on one side, the y terms on one side. Right?
Yes.
Then step number two, on step number two, write integrate both sides. Integrate both sides. And introduce the constant of integration to one side. Integrate both sides and introduce the constant of integration on one side. To obtain a general solution. So on stage 3, this is where you obtain a general solution. To obtain a general solution. Are we together?
Yes.
Then on stage number 3, say use the initial conditions given. Use the initial conditions if given. Use the initial conditions if given to find the constant of integration. Use the initial conditions given to find the constant of integration. And at this stage we have what we call a particular solution. And at this stage we have what we call a particular solution. Are we done?
Yes.
Alright. So firstly, let's try to find the general solutions first. As you can see on the screen, on exercise 15.1, can you write the question saying find the general solution of each differential equation? Then can you write number 1? You want to do number 1 together. Right? Are you done?
Yes.
Okay. So the first stage we said we have to separate the variables. Let me write here. We have to separate the variable. So the first thing you have to cross multiply. That's the first thing you have to do. Like this one is our equation, right?
Yes.
Then if you cross multiply there, you are going to get dy is equal to x dx, right?
Yes.
And as you can see, at this stage we have managed to separate the variables already, because we've got y terms on one side, then the x term to the other side. So at this stage we've managed to separate the variables. So I think we are now moving on to the next stage, where we are going to integrate both sides. So you have to indicate that stage as it is. So we move on to the next stage, saying you are now integrating integral of y dy. We're integrating y with respect to y is equals to integral of x dx, right?
Yes.
So this stage you have to indicate this stage, because this stage is it's simply meaning it's our stage 1 for separating. Then you have to write also this stage for trying to integrate. We are now attempting to integrating this side. So if we integrate this y with respect to y, what do we have?
Half y squared.
It's half y squared. Then to this side, what do we have?
Half x squared.
Half x squared. Then, and we have said you have to introduce the constant of integration to what? To one side, usually to your right side. So plus c. So this one is your general solution. That is our general solution. So it depends with the equation on how the expression is being expressed to. We can further simplify this, but we are saying at this stage we have already find out our general solution, unless if you are given a certain expression by the question where they want you to simplify. We can further simplify this one, maybe by clearing the denominators, by multiplying each term by 2. If you multiply each term by 2, what do you get?
Y squared is equal to
Y squared
x
is
squared
equals to x squared
plus 2c.
plus 2c, right?
Yes.
Then I can say this one is the same as y squared is equal to x squared plus a. Why am I saying a? Because c is a constant. Remember, c is a what? Is a constant, and
Yes.
so if you multiply a constant with another constant, we also get another constant that we are referring to a. So you have to indicate saying where a is equals to 2c, where a is equal to what? 2c. So the simplest way it will be like in this form. This will be our what? This will be our general equation. Or maybe they may say show that the general solution is in the form y is goes to square root of x squared. It's another form depending on the question. So you must know how to simplify the solution. One can leave it like this, one can leave it like this, one can leave it like this. So it depends with the question on how they want the expression to be expressed. So are we together?
Yes.
So can you try number 4? Try number 4, number 6 and 7. Can you try number 4, 6 and 7? And you can send your solutions on my app. Right?
Yes.
So on number 6, the first thing you need to do is to cross multiply. Like if you cross multiply, you are going to have x dy is equal to y squared dx, right?
Yes.
So at this stage, we haven't yet separated the variables. Why? Because we have this x to this side and we also have y to this side with the x. So what we need to do, we have to take this y to this side and we have to take this x to this side. So we are supposed to remove those. So let's say we have x dy is equal to y squared dx so we are going to divide with what to this side. We want to get rid of y squared, right? So we are going to divide with what? With y squared, right?
Yes.
And also the same thing here, we divide with what? With y squared, right? And also this one, we want to remove x, we also have to divide by x, and also to this side you divide by x, such that this y is going to cancel this y squared and this x cancels with this x squared, so that you remain with 1 over y squared here dy is equals to 1 over x dx. Are we together?
Yes.
So after that, we are now going to introduce the integration. So this one, I can write this one 1 over y squared as y to the power of minus 2, right?
Yes.
Is equal to integral of 1 over x dx, right?
Yes.
So if we integrate this one, what do we have?
It's minus y to the minus 1.
Minus y to the power of minus 1, which will be the same as minus 1 over y, right?
Yes.
What about that side?
It's ln x.
Ln x. Then plus your constant of integration, right?
Yes.
Okay, fine. So before we move on to the particular solution, I think we need to do one more example on number 18 or number 24. Or let's start with, I will do number 18. We will do number 18 together. Then you try number 24 before we move on. So on number 18, let's do it together. On number 18, let's separate the variables. What are we going to do here? On number 18,
Cross multiply.
cross multiply. That's the first stage. dv will be equals to v minus 1 dt, right?
Yes.
The next, what are we going to do?
Divide by v over bracket v minus 1.
Yes, so we are going to divide each term, each side by this. So at the end we will have 1 over v v minus 1 dv is equal to dt, right?
Yes.
So in this case, do you agree that we've managed to separate?
Yes.
So after that, we are now what?
Integrating both sides.
So integration of so to your right, it's the same as we are like integrating 1 with respect to t. Yes, it's the same, right?
Yes.
So how do you integrate your left hand side?
I think first you're supposed to expand the terms on the denominator.
Like we are going to
Expand the terms on the denominator.
like having 1 over v squared
Yes.
minus v. Okay, before moving on to the right, what's your next step? Hello? Right, I've expanded. What are we going to do next?
I think you wait. Would it be possible to can I just refer back to the notes so that I can see what I'm thinking is correct?
Like zooming? We are saying we are going to what?
Um, I think like if you keep them, like if you separate so that it's 1 over v multiplied by 1 over v minus 1.
Are you sure? Are you sure?
No, I'm just like trying to
Can
think
you
about.
relate to which type of integration is this? When we did integration, can you relate which type of integration is this?
Integration of product.
Is it of products? Have we done integration using partial fractions?
Yes, you have.
Yes, so you have to partialize that. For us to integrate this, you have to partialize, saying 1 over v minus 1. If you partialize this, what are you going to have? It's a over v, right?
Yes.
You know partial fractions?
Yes, I do.
And v minus 1. Then when finding the values of a and b, it's like a is going to multiply with v minus 1. Then b is going to multiply with the v So like if we say if v is equals to 0, what is going to be your a?
-1.
Minus 1. And if v is equals to 1, what is going to be your b?
1.
1. Right? So integrating this will be the same as we are integrating minus 1 over v dv plus integral of 1 over v minus 1 dv is equal to integral of 1 dt, right?
Yes.
Then if you integrate this, what do we have?
Negative ln v.
Negative ln v here ln v minus 1, right? Because if you differentiate this, you get 1. Yes? Hello? Are we together on this one? Hello?
Hello.
Are we together on this one?
Yes.
Like recognition aspect, we've done recognition, right?
Yes.
When we are integrating this, if you differentiate this, we must get the one on top, then say it's ln of the this one, right?
Yes.
Then here, what do we have to write?
T.
It's t, then plus c, constant of integration, right?
Yes.
Let's say we want to make v the subject here. Let's say we want to make v the subject. What is going to be our next step here from here?
Introduce and expand.
Before you introduce an exponent, whenever you introduce an exponent, make sure if you have the two lines, if you have two or more terms which contains line functions, you have to combine them before you introduce line. Because we can't introduce e here and also introduce e here. We'll be violating. So whenever you have two or more terms containing exponent, containing line function, you have to combine first. Like to your right, this one will be the same as line this minus line this. And you know laws of logarithms. When you subtract logarithms, the numbers will divide each other, right?
Yes.
So it will be line. We are now combining. We are saying this minus this. So it will be line of v minus 1 over v, right?
Yes.
Is equal to t plus c. Are we together?
Yes.
Right. So we only introduce an exponent if we have one line, not two, not three. So after this, we can now say, right, let's introduce our exponential. So that this line cancels and we have v minus 1 over v is equal to like what I've indicated earlier. This one I can write it as a to the power of t. Do you agree with me?
Yes.
Where I said a is equals to what? A to the power of c, right?
Yes.
So if you want to make v the subject, after this we cross multiply, right?
Yes.
And we have a v e to the power of t. Then after that, let's take all terms in terms of v. I can say a, I bring this a to this side, is equal to 1. Are we together on this side?
Yes.
Then we want v. What do we do next?
That's our v.
We factor out v. Then we have 1 minus a e to the power of t is equals to 1, right?
Yes.
Then we what do we do?
Divide by 1 minus.
Yes. So this one will be our general. This one will be our general solution. Are we together?
Yes.
So can you try number 24? Can you try number 24? Maybe I can give you less than 5 minutes. Can you try number 24? So these are the general solutions. When they say find the general solution, these are the processes. So let's move on to particular solutions.
Wait. Before you go down,
Yes.
on number 22, like,
On number 22.
okay, it's fine. Can I just copy it down then?
Okay. Yeah. Maybe I can give you as part of your homework. Let me try to find out which ones you can just try. Yeah, thank you for that. Let me delete this one. So if you can try them on your spare time. Number 22, right?
Yes.
And number 19, then 20 as well. These three. 1, 2, and 3. You can try these ones.
I've copied them.
You are done?
Yes.
Okay, fine. So let's move on to particular solution. On particular solution. So the question will be like this. So can you write this question? Find the particular solution of each differential equation using the initial conditions given. Find the particular solution of each differential equation using the initial condition given. And we want to do number 2. Can you copy number 2? So this is the question and these are the initial conditions. We want to find a particular solution and copy number 2. This is our differential equation and these are the initial conditions that we are given. You are done?
Yes.
Right. So the process is the same. Let's separate the variables. By first cross multiply. Are we going to cross multiply or we are just going to okay, let's cross multiply. What do we have? We have x dy, right? Yes, cos to y dx. Are we together? Hello? Are we together on this one?
Yes.
We want to separate the variables. Next, what are we going to do?
Divide both sides by x and y.
X and y. So that to this side you are going to remain with 1 over y, right?
Yes.
Dy. And this side you have 1 over x dx, right?
Yes.
Then after that we are going to what? To integrate. Integral of 1 over y dy is equal to integral of 1 over x dx. Do you agree?
Yes.
Then what is the integral of this?
Then y.
Ln y. The integral of this?
Then x.
Ln x. Then you say plus what?
C.
Plus c. This will be our general solution, but we want to find the particular solution. So before simplifying and taking terms with ln to one side and simplifying, we have to find the value of c first by substituting these conditions that we are given. They are saying y is equals to e squared when x is equals to what? E, right?
Yes.
So we want to find the value of c. So where there is y, we are going to substitute with e squared. So it will be ln e squared is equal to ln e plus c, right?
Yes.
And this squared goes down this side. We have two, laws of logarithms, right?
Yes.
And what is ln e?
It's 1.
It's 1. So what will be the value of c?
1.
1. So your c is equals to 1. Then after getting the value of c, we are now going to substitute it here so that we find a particular solution. So our particular solution will be, it will be ln y is equal to ln x plus what? Plus 1, right?
Yes.
So maybe if you want to find the value of y, if you want to make y the subject, what will be our next stage? What are we going to do if you want to find y, if you want to make y the subject? What are we supposed to do?
Introduce an exponent.
We what?
Introduce an exponent.
Like that? We said before you introduce an exponent, make sure all the terms in terms of logarithms are in one side. Because here, as you can see, there are two terms, like ln y and ln x. Why can't we just take them to one side, like on the left side? Then we simplify, then introduce the exponent later, if we only have a term in terms of ln. So if you take your ln x to the other side, it will be ln y minus ln x, right?
Yes.
Is equals to what? 1. Then these terms, they are subtracting. These terms, they are subtracting. What do we have?
Ln y over x.
Ln y over x is equal to 1, right?
Yes.
Then after that, now you can now introduce the exponent. Then the 2 will cancel. Then you have your y over x is equals to e to the power of 1 is just e, right?
Yes.
So finally, what will be your y?
Xe.
Xe. That will be our simplified y. That is our simplified particular solution. Are we together?
Yes.
Fine. So can you try this number 3? It's cos y dy dx is equals to 1 over x with these initial conditions. Can you try number 3? It's cos y dy dx is equals to 1 over x. Sorry, 2 minutes. I'm giving you 3 minutes.
Um.
Don't worry. Waendera kuchipatara nikadhi karakufunda ridya masikati kwete manheru. Imboridya masikati paunonzwa nzara paya unotonoita sei? There's not meant for manheru. Manheru kungo kune malaita. Wambotraira kuti vasema let me go to number 17. Yes, let's do this. Can you copy number 17? You want to do it together. It's a typical exam question. All these questions with a C to the end, it's for Cambridge. They're past exam questions. Can you copy number 17? You want to do it together. So it's a typical exam question. Like I said, you know, they want you to prove the particular solution in that form. You see?
Yes.
Number 17. So you don't have to run away from their answer. You have to prove it as it is. Right, are you done copying?
Yes.
Okay. So we are given that differential equation. So the first thing we need to do is to separate this one. The first thing we need to separate, maybe by cross multiplying, we will have dy is equal to square root of x e to the power of y, everything in square root, then dx. Are we done separating?
No.
No. Why?
There's a German Y on that side.
Yes. So we are going to separate. And how are we going to separate x and e of y? Square root is something like everything is to the power of what?
Oh.
Yes. So it will be dy is equal to x to the power of half. Then what do we have for e? It's e to the power of what?
Y over 2.
Yes, half y. Dx. Then after that,
Divide by e to the power of half y.
yes, 1 divided by e to the power of half y dy is equals to x to the power of half dx. Right. So are we done separating?
Yes.
So next we are now at
Integrate.
so maybe simplifying this one. This one, if it goes on top, it will be like e to the power of minus half y, right?
Yes.
is equal to what do we obtain to our left? What do we have to our left hand side? What's the value of the integral to your left? Hello?
Hello?
What's the value if we integrate this side?
I'm not sure, but I think it's minus half e to the minus half y.
Because if you integrate this, we are going to say you take it as it is, right? E to the power of minus half y, right?
Yes.
Then you divide by the derivative of the power, which is minus half, right?
Yes.
Then we have what? Here to this side is x to the power of what?
2.
3 over 2 divided by 3 over 2, right?
Yes.
Then plus what?
C.
But it's not in a proper way. Right, this one dividing by minus half is like multiplying with minus 2, right?
Yes.
And also dividing with 3 over 2 is like multiplying with what?
2 over 3.
2 over 3. Then plus c. So before simplifying further, let's see if we have particular solution, initial conditions. We have the initial, right?
Yes.
x0, y0. So let's go and substitute. Where there is y, let's put 0. Where there is x, let's put 0. If we put 0 here, it will be e to the power of 0, right?
Yes.
Then you have minus 2 here. And if you put 0 here, everything disappears, right?
Yes.
Then we have what? C. So our C it's minus 2. Then let's go and back substitute to our general solution. Then we have minus 2 e to the power of minus half y is equal to 2 over 3 x to the power of 3 over 2, then minus 2, right?
Yes.
And as you can see, we want to make y the subject because they are saying sure that y is positive. So let's make y the subject here. From here, let's make our y the subject. But before making y the subject, because y is on power, e to the power, we have to get rid of this minus 2, right?
Yes.
So maybe you can write aside, say divide each term by minus 2, right? To your right, far right, that divide every term by minus 2. Then what are we going to have?
E to the minus half y.
E to the power of minus half y. So this is negative. And here, like here, if you divide minus 2 with minus 2, you get 1 for this, right?
Yes.
Then this one, if you divide it with minus 2, you're going to get minus a third, right?
Yes.
X 3 over 2. Right?
Yes.
So what's next?
Introduce limits.
Yes. How? We're going to say ln e to the power of minus half y So please, when you introduce ln, you only introduce lns once. One ln to one side, one ln to the other side. So to your right, it will be like ln of that everything. It's ln of 1 minus a third x to the power of 3 over 2. Are we together on this one?
Yes.
So don't introduce saying like to your right, saying ln 1 minus ln of this. No, you introduce the ln of everything that you have here. Yes?
Yes.
So now this one is going to, then your ln e is 1. So to your left you have minus half y is equal to ln 1 minus a third x to the power of 3 over 2. Right?
Yes.
So then we want to make y. We are going to do what? We want to remain with y.
Multiply by minus 2 both sides.
We are going to multiply by minus 2 both sides. Then we are going to have y is equal to minus 2 ln of 1 minus a third x to the power of 3 over 2. Like this. I think it's the one which is required. It's be required. It's the same, right? You see?
Yes.
So sometimes they ask you saying make your y the subject in that form, then you have to show it like in that way. Was this clear, or you need to be highlighted somewhere, somehow? Is it okay? Were we together on this one?
Yes.
Okay. So maybe if you can take note, can you take down number 15 and 16? Can you take it down?
Done.
Okay, so let me try to search for the papers that I was selecting. Let me try to see on this one. So tomorrow we are supposed to do the formulation. What we have done here is to just solve that given differential equation. So tomorrow we will be formulating those differential equations. We'll be formulating differential equation. For today we have just managed to solve the equation, but for tomorrow we want to formulate any. We'll be given like we'll be given a statement whereby we are going to come up with our own differential equation. So here it's number 7. Let me take the screenshot, then I will send you. Here it's number 7. As you can see, you are given this differential equation, right?
Yes.
Then it is also given that y equals to 2 when x equals to 0. Now these are the initial conditions, right?
Yes.
So they are saying solve the differential equation and hence find the value of y when x is equals to 0. So meaning to say you are going to solve this differential equation and make your y the subject. After making y the subject, you are going to find the value of y when your x is equals to what? 0.5. Okay, fine. I have taken the screenshot. Let's move on to the other one. Let's see if we can find on this paper. Let me see if we have any differential equation here. Right? This one again. On number 5. As you can see, number 5 is the same concept. We are given the differential equation and those initial conditions. You can see.
Yes.
And they are saying y is equals to 0 when x equals to 0. Solve the differential equation, obtaining an expression of for y in terms of x. So again, this one I've taken the screenshot. I will send you. Let me see this one again. Right. So tomorrow we'll be looking at question like on number 5. As you can see on number 5, we are given a statement, and as you can see on part A, they're saying form a differential equation. So tomorrow we will be looking on forming a differential equation. Then after forming the differential equation, we'll be solving that differential equation being formed. Right? So this one is for tomorrow. Let me see if I can have the other one. So for 2021, let's see, May, June 2021, what do we have for that paper? Oh, right, this one, 11 marks. Are you seeing this one?
Yes.
Let me take a screenshot. And also they are also giving you a clue. You see, they are saying This one is our differential equation. Then they give you a clue using partial fractions. You are given a clue on how are you going to solve that. You see,
Yes.
otherwise they would say just solve the differential equation, and you are going one will be playing gymnastics there. But in this case we are given the clue, so we are going to use integration by partial fraction, and you have 11 marks for that sake. Let me see on the next one. Do we have any DE here? Seems like on this paper there was no DE. Let's look at this one. Some of the components repeats the question, so you define that one of the component paper carries. You've got a differential equation.
Which component is the hardest?
Hello?
Hello? Which component is the hardest?
It's like you write paper 3, but there are different components. So where you are going to register, they will tell you that it's paper 3, like this paper. If you can see, let me go to the. I'm trying to find a. Oh, you see, there's a differential equation here. You see this one, there's a differential equation here, but the first thing was to come up with that. So this one we'll look at it tomorrow. Then after that they say solve that DE. So this paper has got a component, but they want you to formulate it first. So when you register, they will give you a slip, or they indicate the components that you are going to write. So this one is it indicates this one, it indicates the component. So let's say you are doing P1, right?
Yes.
And P3. Which other components are you supposed to do?
Stats and mechanics.
Okay, you are doing physics.
Yes.
Okay, so it starts in mechanics. So when you register, the slip will be indicating, maybe like this paper 3, they will say you're going to write maybe component 3.1. Here maybe you write paper 5 is it's 5, and it's paper it's paper 5, right? So maybe here they will say component 5.2. Here they can say component 4.3. I'm not sure if they are consistent with this component. Here they may say component 1.3. Because when they set the papers, the paper ones will be in components. Like say maybe someone writing at Hillbright will not write the same paper with your institution. At Hillbright maybe they will write component 1 3 and you can write component 1 2. It's for their security reasons, but the syllabus and all the concepts will be the same. They just differ the questions. So
So there's
when
no
you
difference.
register, it's where you are going to say which components exactly are you going to write. But it's just P1, P3, S1, and M1.
All right.
So have you started any topics in S1?
Yes, we have.
Or you are doing online?
No, but then
Yes.
before we closed last year,
Or
we did a part of stuff.
you did S1 last year?
Yes, part of it,
Oh, so
not all of it.
you are going to write all these papers this year, right?
Yes.
Okay, fine. Here on mechanics, you will be just looking at questions because you are already covered in physics. Just one or two concepts which applies integration and differentiation to kinematics. But you are on safe side if you are doing physics. So I think for tomorrow we are left out with just formulating the differential equation. Then we will be done with this differential equation. Then maybe during the weekend I will give you one more test before we proceed to which one do you we are going to proceed to numerical method because it's another application of integration and diff. So we will move to numerical methods after that, right? After differential equation. Will you be available tomorrow at 5 or will you be preparing for Sabbath? What time do you prepare?
All available. I'm usually done by maybe 4.
What time are you free tomorrow?
Anytime from 4 o'clock.
Anytime from 4.
Yes.